Hello everyone, this is Mr. Ege and this is going to be in brand new STEM design class activity. This is called the gyroscope and we're going to have two parts drawings and one assembly drawing at the end. The first part drawing will be the gyro cap. You're going to call it gyro cap and save it in OneDrive. And before you start your Inventor, I have to tell you this can be done in AutoCAD and Inventor. However, AutoCAD instructions will be different. I'm not providing that right now. I'm helping you with the Inventor. And this is the lesson that if you follow instructions letter by letter, it's going to be a workout for you. If you have any questions, of course, you can always raise and stop me and call me, and then I come next to you and help you. So what's a gyroscope? I hope you find the PowerPoint presentation explaining about what gyroscope is, what it does, how it operates. There is a whole world of science behind that gyroscope, and it's a relatively new system. Even though it's been around for several hundred years, it's not around for thousands of years. So, but it exists. Gyroscopic forces, they exist. Centrifugal forces, it exists as long as the universe has been around. So this is one of the very important forces and concepts to exploit. And it's being exploited electronically currently and mechanically. So please start your Inventor and please set your system part drawing, create a part drawing, and make sure that your part drawing is configured in inches. And how do you do that? You basically go to Tools and Document Settings. Under the document, select Units, make sure that it is in inches and the mass is in pounds, and pretty much everything seems to be orderly shape here. Under the Documents, Tools, and under the Document Settings, and close. Second, make sure you save it in OneDrive. We are, even including teachers and students, we are all allowed to save this drawing in one place only, in OneDrive, okay, under a folder that carries your name. And if you confuse this, you're running a risk of losing entire drawing, hours of work. And this did happen before to my other students, so that's why I'm warning ahead of time. Actually, if you're not sure, call me. Let me take a look at it where you saved it. Okay? All right. So when you start a part drawing, first thing you do is you select a plane, X, Y, or Z, X, Y, Y, Z, or Z, X plane, and you go to Origin, click on the plus button next to the Origin. It opens the folder for you. And this is going to be, I'm going to create a sphere first. So I'm going to select YZ plane. Okay, click on this. As soon as I click on the YZ plane on the browser on the left-hand side, by the way, if you don't have a browser, you make sure you have it. Okay, as soon as you click on it, this particular button in the screen menu button shows up in the center of your drawing area, and create sketch button, and click on it. That sketch is created, and this is the XY plane, but it shows you the right. This is actually literally the right side view. Even though the view that you're looking at, X and Y, okay, you actually YZ plane, and right side view shows you, it demonstrates you that this is the right side view, actually YZ plane. Okay. How do we create a sphere in Inventor? It was easy in AutoCAD. You go to primitives and but no, in the Inventor you have to generate a line as much as the diameter first. So start from this point, and what is the diameter of the quarter of an inch of the sphere? 0.25. So 0.25. I'm typing this number now and enter, and line is created. Good. I'm hitting escape key. Now I need a half circle, but I suggest you to generate the full circle first, okay? And then trim the left side, perhaps. There you go. Now we have a half circle. And this will be revolved 360 degrees for 360 degrees. So finish the sketch and change the angle so that you can see what you're revolving. And go to 3D model and go to revolve command. Select the area and then move your cursor to select axis. Axis is vertical line you just created. And click on it when it's highlighted. Don't click on it if it's not highlighted. I did, and okay. Here we have the sphere. Material. We need to choose a material. There are many materials available. I'm choosing malleable iron. Okay, there you go. Okay, so far so good. And now we need to save this. So file save as. I'm going to save it where it's supposed to be, but naming is very important. Naming process is extremely important. So I'm going to call this gyroball. Gyroball. Capital letters even. Byege. Do not putting your name in the designs. It is extremely important in the world of industry, in the world of technology, in the world of engineering, in the world of business, that you use your name, company name, as often as you want, and actually more often than necessary so that people knows. This is a part of the marketing technology. Good. So the gyroball is created, but now we need a handle. So I'm going to go to right view again, and this is my viewport, view cube on the top right side. This time I'm generating a rectangle. The rectangle size of the rectangle, again, this will be revolved too, will be the dimension that I would like to have, that I designed on piece of paper. Right now you don't see it, but right next to my computer, laptop, I have a sketch paper with all the dimensions that I designed earlier. I want you to tell you, number of the things you don't see my screen is actually typical design tools, a sketch paper, a graph paper with the squares on it, and the pencil and the pen. Okay? I have everything around me. Okay, I designed this in my head. I put it on the paper. Now I'm transferring all the information on the inventor. So this is the way it's supposed to be. This is a critical professional approach of generating solid models, digital models. Okay, all right. So I'm going to go back to again origin. I'm going to choose YZ plane again. Same way. Click. Okay. I'm going to start a sketch, all right, and this time I'm drawing a line. How far? 3/4 of an inch, 0.275. Enter. And this is going to be rectangle I mentioned to you, okay? And I could have started with the rectangle command, but I did not. Now 3/16 of an inch. So it's going to be 3/16 of an inch, and I'm going to drive 3/16, enter. And now I'm going to draw a vertical line, lining up with the end of the line, and then click here. Okay. Now I realize this is a little bit bigger, 3/16 of an inch. Actually, it should have been 3/32 of an inch. So I'm going to change that number, 3/32 of an inch. 3 divided 32. Enter. Okay, that is more correct. Okay, and now I'm going to change the angle so that I can finish the sketch and revolve it. Select the area to revolve and select the axis button and make sure that it's highlighted when I move my cursor over the axis button and revolve and OK. Okay. What is the relationship between these two? It has to go halfway in. I can push it by hand by my move commands. However, I have better tools, so I can use the move command and move everything. Okay, move bodies. I'm just going to go to modify and select the move bodies option here. And X offset. Okay, nothing. Y offset. An eighth of an inch. Let's go 1/2 and see how it goes. Oop. I'm going to try one more thing. Okay, perhaps I'm going to go back to grease the move body. It's not, it didn't give me the result that I expect. Go to sketch, okay, and use the move command. I'm moving the sketch now, okay, and I made a selection. I'm just choosing the base point from the center point to the center point. Okay, this is more like it, and finish the sketch. All right. Looks like this is working now. And one more thing you can do, perhaps, and you go to 3D model, okay, and then choose the fillet command and select the joint between the head of the handle and OK it. Okay. All right. Of course, every often you finish something, just click on Save button. Okay, so far so good. What else do we do? We need to create a cone. Okay. I'm just going to go back to sketch number 2. And I'm going to generate the lines for the cone. Okay. The distance from where I start approximately 0.86. Enter. Now I'm going to move exactly 0.86. Now you're probably wondering, where is this coming from? Numbers. Those numbers, Mr. Ege calculates it, computes it. And one-on-one, I can explain this probably better. If I try to explain every single geometric calculations I made, this probably video will never finish. Okay, and so 0.86 is a mathematical equivalency of the cosine 30 degrees. And there's a reason why I did that. Okay, and this is almost perfect, but do you see this point, intersection? And I want them to be intersected with each other, and for that to happen, I'm going to move this triangle, isosceles triangle, a little bit up. Okay. So I'm going to shift, click and click and click on that, and from the base point, and move up a little bit higher on the same line. There it is. Done? Okay. So I'm done with the finish. Should be sketch. Now I'm going to go back to revolution. I'm going to add the additional revolution. Okay. 360 degrees revolution around the select the axis. Okay. And okay. All right. So this is almost there. This is the gyro ball, the cap part, and I would like to have smoother finish here. Okay, anytime you have a sharp corner, usually it collects dirt, and engineers, architects know all about this. So I'm going to go with the fillet command and choose this corner and okay it. All right, and save, of course. So far so good. We're almost finished with the cap. What else do we need? We need a hexagon. All right. So I'm going to look at the underneath of this surface, okay, and select the surface and create a sketch on that surface. And I'm going to go create a hexagon, polygon, hexagon, and then choose the hexagon. Okay. Size of the hexagon, computer is asking me, will be 1 inch diameter or 0.6, 0.5, its radius, and right now it's more or less correct size. So what I'm going to do, I'm going to extrude this about 1/8 of an inch. Finish the sketch, extrude, select the hexagon, and 0.125 extrusion. Okay. Good. Okay, it's more. I don't know if I can do this fillet here. We could always try. Probably we don't need it. And 0.125 is too much, maybe 0.5, 0.1 will not work. How about 0.05? Perhaps not going to work. We can leave it out like that. We don't have to do it. There's not enough room for the fillet here. Okay. So this can be done without the fillet. All right. Next extrusion will be another hexagon at the bottom. So we're going to choose the bottom surface, create a new sketch. Okay. All right, so we're gonna go select a polygon again, and it's a hexagon. Okay, we're gonna choose the center point, and this time the hexagon that we choose is going to be less than 1 inch of a diameter. We're gonna allow this to be slightly smaller. Okay, the previous one was 1 inch, and internal size is going to be 1/4 of an inch or 0.75, 3/4 of an inch, 0.75, and this is going to be 0.7 inches. Okay, because it should be a little smaller than the available space inside the body, gyro body. Okay, so I'm going to go with the 0.65. Okay. Probably the best way to do this, dimension it. Okay. I'm going to make a little bit the dimensional changes. Okay, the diameter I want it to be from the sharp end of the hexagon to sharp end is going to be 1 inch, and I'm going to put the dimension there. Okay, and then change the dimension to 1 inch. Okay, and that was going to turn it in. Okay, something like this. Finish the sketch. Okay. Now, internal dimension of the hexagon is going to be 0.65, because it's going to fit in a hole of 0.75. So there is approximately 1/10 of an inch difference between hole and the cap that fits inside. Okay, so 0.65, 0.75. All right, this is about the same size. So the hexagon from sharp end to sharp end, corner to corner, dimension is 0.65. And if you go to sketch number, previous sketch, the largest hexagon has 1 inch diameter from sharp corner to sharp corner. And I just want to show you this, okay? And now I'm going to extrude this particular sketch. Okay, so we are all done, and now I'm going to go extrude command. Okay, and 1/8 of an inch extrusion. Okay, and done. Okay, it's going to look like this, and this is the cap or gyro cap. All right, and you're supposed to be holding the handle on the top and then rotating. Okay, very fast. Okay, and this part, the cap part, will fit the gyroscope. Okay, now, so this is one drawing which is finished, so you can save this. Now we're going to start the gyro body. Gyro body is going to be made from pretty much the similar as 1 inch diameter hexagon. So I'm just going to, after the save command, I'm going to go to File and click on New, and select the English units, standard IPT, and I'm going to go create button. Okay. All right. So I'm going to use the same YZ plane. Oh, maybe not. How about XY plane? I'm going to use the XY plane. Okay. and start a brand new sketch on the XY plane. All right. And I need the hexagon. Go to polygon commands, choose the hexagon. Okay. And this is going to be 1 inch diameter, or radius of which half inch. Okay. As soon as you create it, please make sure that you you click OK, and then go to dimension, and you make sure to dimension it. Okay, and that is 1. Okay, good. So now that this is done, we can extrude it. How much? It's going to be another 1-inch extrusion. Finish the sketch, extrude, and that's going to be 1-inch extrusion. Okay. Okay. What else do we need? We need to empty inside of this. Okay. And let's go and select this surface. Start a new sketch from the plane and create a polygon and choose the center point. Okay. Now we're done, but dimension it first. I want the wall thickness to be 1/8 of an inch. That means it gives us 3/4 of an inch distance, internal clearance, so 0.75. Okay. And I'm going to extrude this, subtract extrusion, finish the sketch, cut extrusion. 7/8 of an inch. 1 inch would be total hole. We don't want that. And we want this to be 0.7, okay, 7/8 of an inch. 0.825. Eight seven five, 0.875. Okay. All right, that's a perfect extrusion. All right. Now notice that we left the protrusion part of the cap. Okay, 0.625. So 0.625 is slightly smaller than 0.75. So it's going to nicely fit inside this. Okay. This particular difference, 0.1 inch difference between hole and the cap that's going to fit inside, okay, is called tolerance. And when you're fitting a part into another part, there are multiple rules. And there is going to be a special class dedicated just for the tolerancing, dimensioning and tolerancing in the engineering schools. If you go to engineering schools, there will be a 1/4 no, I'm sorry, 2/4, 1 semester of class, okay, dimensioning and tolerancing, and the relationship between hole and the cap between the hole is going to be there's specific rules, okay, and tolerances, and then you'll be learning all of these, okay, like a pen and the cap of a pen, for example, or a glass and cap of a glass, or pitcher, and they have all different kinds of relationships. Okay. All right. So this hole supposedly slightly larger, but it's not too large enough for the cap to fall out. Okay, it's going to barely fit in. Okay, So now, so far so good. Now we have the gyro body. I'm going to save this as a drawing. Okay, save as, and it's going to be a gyroscope. Yeah, I'm just going to type it. Gyroscope. Or we can call it gyro body. Gyro bot. Save. Right. It's not finished yet. Is it finished? No, it's not finished yet. Again, we're going to continue, okay, with the sharp bottom end over here. And we're creating a new sketch. And here, I'm sorry, here's what I'm going to do. Finish the sketch. This is not the sketch I wanted to create. I'm going to erase, delete the sketch. Okay. What I like to do, I like to create a plane, first of all, okay? To choose a plane. I think YZ plane works good. We create a new sketch. And I want to draw a first line, 0.86 divided by 2. 0.86 divided by 2. Okay. And this is going to be isosceles. Again. Triangle. Something is not right. And point 43. Enter. Okay, so apparently, I'm not even sure if we're in the right plane or not. I'm going to just finish the sketch. Okay, I'm going to delete the sketch. I'm select the plane again one more time. And I'm double checking if I'm creating a right plane. Yes, I'm selecting the right plane. Okay. And I'm drawing the line. 0.43. Enter. And 0.43. Enter. Okay. All right. And before I finish the sketch, I'm going to move it up where it's supposed to be. And move command. I selected what I'm going to move, and start point, from point. I'm going to move all the way up and down. Now I'm going to revolve this. Finish the sketch. Revolve command. Select the item. Select the axis of revolution. Do that again. Okay, revolution is done. And okay. Cool. Basically, this is the gyroscopic body generated. Okay. Now, the question is, can we put it together now in an assembly drawing? Now, I'm going to save this, okay, gyrobot, okay, and I'm going to check a few other things. For example, tools, document settings, are the units correct? And they're all good, 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 good. Okay. Now I'm going to put these two together, and I'm starting a brand new gyroscope assembly. Click on New button, go to English Units, and Assembly, IAM. Inventor Assembly .iam. This is what I want to create first, or create. Okay. And select YZ plane. I don't have to select any plane right now, but I did. But honestly, I don't have to. So what I'm going to do first, place, okay? There it is. All right, I'm putting one here and another one over here. And one over here and one over here. So the reason I put two of them, I want to demonstrate some of the things, assembly, how it is done, okay? This particular cap will fit inside here, okay? And for that to happen, I'm just going to position it first, okay? And even I'm going to select it and I go and free move right mouse button and free rotate first. Like that. Okay, so this first activity is about how do you join two parts in an assembly drawing. How do you join these two parts together, okay? And that will happen through the join command. We have a join command, and if you move your cursor on the join command and wait long enough, it says applies relationship which determine the component placement and motion, okay? So that's just for applying the relationship, okay? It's for the looks, but it's important, it's for the functioning at the same time, okay? So how do we do this? Go to join command and choose a joint. Now, would automatic joint fit? It might, okay? But the question to answer is, how do you fit this? All right, so there are a number of things to demonstrate, and one of them is the surface. They interact with each other. The interfacing surface. This is the interfacing surface. I click on it, okay? And now you choose the other interfacing surface. with the same corner. Ta-da! Apply it, and we're good. Okay, do you see now how it fits perfectly? And we apply the join command. All right. And if you can print it out like this, okay, so this gyroscope is going to work very nicely. It will spin beautifully. All right. But this is not the way we're going to print it, because if you print it, this cap will never open. All right. So I demonstrated this so that you can use the join command. Joints are special relationships between moving parts. Okay, when you have two related moving parts, you use the join command. But this is not the way necessarily you want to print. Okay, so the big question is, how do you want to print it? How do you want to print this is a different question. I think this handle is perfectly standing up the way it's supposed to be, but apparently the body has to be a little bit different. So I'm going to free rotate this body. Okay. So I'm suggesting this is the printing position. Okay, so this is the printing position. This is the way I'm going to save it. Okay. And just please name it gyroscope by your last name. Okay. Thank you very much for your time, and I suggest you to print out this design of your own, and then just want to continue with the new and more interesting even areas. You don't have to do the second part. This is the printable part, and I suggest you to print this, okay? And in order to print something, you have to export an XTL file, okay? And you go to image option, and you change it to STL. Let's do it again. Export, okay. CAD format, and then STL file. options, make sure that it's inch action. And sometimes I change it to millimeter option because our 3D printers, they operate on the millimeters. So I change it to millimeter option. If I don't do it here, it's going to be difficult to readjust size later on. Not difficult necessarily, but it's inconvenient. High resolution, low resolution, medium resolution. Okay. Thank you very much. See you later.